We'll just wait for a few minutes and then start. In the meantime, if you guys have any questions, feel free to ask me. Yes, we can start. Um, so yeah, last class, yes. Last class we saw about const casting, where we took some more examples about it. And let's say we have a function called print that just takes non-const arguments of something like this, say, character pointer. Here in this case, and let's say we have a string which is of character pointer, but also of const data type. To avoid writing overloaded functions, like just have load like load of code. So you can do it, but it's not exactly necessary just for this one case you need to write it. So you can avoid that by using const casting and make your string non-const for this instance, right? And yeah, it will print it. And the example we saw is for just a second. Yeah, sorry about that. So yeah, we took example of classes also. So let's say we have defined a class like a const, right? So here you have to remember uh, your class members are accessed by the this pointer, right? So that's what we saw. And when you're trying to get access any of these internal elements, okay, your variable themselves, like for example, in this case, is not necessarily const, right? But the pointer that is being used to access these variables itself is const, because this pointer refers to the object in, which is of const data type. So its pointer, which is this this, this, that is of const data type. Okay. So very similar to the print example like we have here, you have to make it not non-const to access. And so access here is not a problem, okay? Because you're just reading the data. If you're trying to write to it, again, changing the data, so then you need to do a cost casting. Okay, that's sort of the summary of it. Okay, right. Now, moving on. So reinterpret cast. So we also see about static cast and reinterpret cast, right? There's a different form of typecasting where reinterpret cast. What's the question? Yeah. Okay. Right. So the main difference, like between static and reinterpret cast, is that reinterpret cast it does not change the structure of the bits, underlying bits. Okay, it reinterprets in a different rule. You can think that way. It could be float, double, integers, long integers, whatever. Okay, right. So that's what our reinterpret cast does. If you take static casting, here it tries to convert from one data type to the to another, where especially if the, how do you call it, types should be related. Okay, by that I mean is if you have integers, doubles, so there are rules. So there are rules to convert one from the one to the other, as in it can look at the actual number, decimal representation, and then know how to represent the same number in decimal representation, okay, in another data type, right? So these types are related. So for those types, you can use static casting. Okay. Let me take examples of typecasting from integer, long, double, and how each of these work. You can do the similar thing, okay, like very similar thing in both C and C++. The syntax is a little different, okay. Um, the reason to use the C++ syntax is that your intention is clear, okay. And again, the clearer your intention of writing the code, the more bug-free or error-free it will be. Okay, so that's a good practice, right? Another thing is you can change pointers too. Okay. Yeah. So that, yeah. Here we took example of pointers. Okay. Double and pointer. Then we typecasted to read the data. Here, if you take the same very similar example, but we're using void pointers also, right? Um, So technically speaking, you can use interpret cast or static cast both, okay, to read off void pointers. There's not, but the more semantic way is to use static casting checks for type um, compatibility at compilation time. So you will get errors if it is not um, type compatible, right? So to avoid errors, the more semantic way is to use typecasting, using static casting. You can use reinterpret cast, but it won't be as strict as static cast. So you just lose on some of the safety that static casting provides. But nonetheless, you can use, or at least for this example, where we actually took a pointer integer or pointer um, double, and then just um, let's say I cast it into void pointer, okay, and yeah, so you can use this, and then when you cast it to a void pointer, okay, the type is lost, but underlying the data structure, the actual bits, right, that has not changed. So the addressing, where the address starts for the integer or for the double, that information itself is still there. So for void pointer, if you reinterpret that data, it's fine. And if you try to typecast it from void to a integer or a void to a double, also it's fine. It's just that the static casting will do an extra check. Okay. Hence, static casting is actually more semantically used. Okay. There's nothing stopping you, just what I'm saying. There's nothing stopping you from using reinterpret cast. If you know that it is indeed the underlying thing is actually a double or integer. Okay. It's just a extra layer of security kind of thing that way. A brief on this we can just cover today also. So, okay. Yeah, so fine. And protocols. As a new file, we have dynamic casting. So, question last week about this. So, it's essentially like I can just take this example instead. Start with the main function. But file says okay. Um, for a lead function, the pointer with where I So that I'll put the address of I itself. Okay. Double pointer. Sorry. Yeah. Yeah, double pointer. Okay, read equals to this. So we set the um, opposite values first. Okay. Uh, yeah, okay, that's okay. Now we need to typecast it. Go back. So yeah, just use dynamic cast. Then just give the figure pointer. The itself. And for the second part, can we do this or double stack cast or double point? Now the main difference between static cast and dynamic cast, I think you guys can guess from static allocation and dynamic allocation. Pretty similar stuff. Static allocation happens at compilation time. Uh, the check itself happens at compilation time. So while compiling itself will get the error. Dynamic casting does it at the runtime. Okay, that's the essential difference. There are use cases where you might want one over the other. Again, it completely depends on the use case, but it's just there, just something to be familiar with and know. Okay, that's the right. Okay, right. Mm, yeah. So, uh, right. Any specific questions or yeah, okay. So moving on, let's yeah, let's move to a very important concept in C++, which um, has a lot of use cases. So one important thing is definitely it helps you write code and reuse it a lot. Okay. Yes, functions are certain something like that where you write code once and reuse it a lot. But templates go take it a little more further. Okay, that's one point. And second point is from performance perspective, templates are also very useful. So look at that. Let's start. So IO string. So let me define a function called max. Okay. So let's say this is of it compares again. I think it's obvious. It compares two variables. Okay, and returns the max value. So you can just write it in a single line using ternary operator. Okay. So you check A if A is greater than B. Okay. So the true clause will return A. Okay. Else then that's the colon that starts the else part, else return B. Okay. You can put brackets here for more clarity. But yeah, nonetheless, this is essentially what the max operation is. Okay. Again, write it in a very if a statement wise also. Okay, instead of a single line. If A is greater than B, then you return A. Okay, else you return B. Okay. Straightforward, right? Yes, I got it. For now, just comment. For now, I'll just comment this block, but I hope you guys get the idea. Right. So this is a function which compares two inputs and returns the match value. Pretty straightforward and simple function, but this will help us build the concept of templates. Okay. So now let's say I want to compare two values. So I can just put standard cout. Let's say max. Okay. So I'll put, let's say 1, 2. I'll just pass the values. I'll not define A and B and pass it separately. I'll just pass it and then so that the return itself gets printed here. Okay. Oh, sorry for that. Standard and 9. Done. Okay. Right. Okay. Any questions so far? Let's just go ahead and print this. So, okay. It's 2. That's correct because 2 is indeed greater than 1. So the code is fine. Okay. Now, what if I want to print the same thing? Okay. But now I want to use the same, like similar idea. This time I want to compare, let's say 1.1 with 2. Oh, so if I just compare it again, it will generate a warning because, yeah, this is important here because if the warning wasn't there, okay, if you had suppressed all the warnings and just compiled this, okay, would have compiled and ran it, right? Okay, but it may not be the intended thing that you wanted because there was an implicit conversion here from a double to integer. And because it can only compare integers to integers, right? Okay. So again, this really depends on a compiler if it will throw an error or as in it will not compile, throw an error and not compile, or it will just implicitly convert it. Okay. So this gets a little tricky because then how do you ensure that you're actually passing a double and then it gets compared with the correct data type? Okay. So you can do one more thing where you write the same thing. Okay. But this time, instead of returning integer, you return double. Also, the inputs themselves do not take just integer. Okay. They take double also. Right. So now when you take values like this, they can be double and you'll be all good. So integers also allowed, doubles also allowed. Okay, so now let's say we compile this. Okay, so now this is because it gets confused what actually to call. So let's see, I think this should fix it. Yeah, I explicitly said that I'm using the integer definition here, and in this case I'll use both of them as double. So I just use the point like writing it as 2.0 treats the number 2 as double. Okay, right. So in the hence you are able to use this definition for the second case specifically, and the first definition for this first case. Okay, but if you see the actual body of the function, it is exactly the same, right? The only difference that at all happened was that you had a return type and the input type being different, and we had to rewrite the whole code, right? So yeah, to avoid bloating of code like this, which is what we just observed now. For this very example, right, we are going to motivate templates. Okay, that's the idea. There is another way in which you can sort of achieve the same thing. But yeah, before moving templates, let's look at that example too. So let's hash include string define. I will go. I'm going to use macros. Okay, so that's the short of it. Instead of just rewriting and writing functions, I'm going to just use so we use okay. So what a macro does is it essentially replaces your string of macro with whatever defined string it is. Okay, that's how the defined macros work. So specifically here, we want this is the body of the macro within this. So specifically, I want to use A, okay, the value of A. I'll compare with the value of B, okay, so that I can use the ternary operator. I'll use the values themselves, okay, and I am going to just let the compiler figure it out, the data types and return types by itself. Okay, so write the main function exactly same as before, standard cout. But instead of just the max, I have to use the macro. So hence the little style different. Okay, you can use max with the like first capital and then all small. That case also, but as in syntax case. But again, we'll respect the rule of defining macros. You capitalize all the letters. Okay? You can use other underscores with the combination, but again, I'm just sticking to just all capitals. Okay. So comparing 1 with 2, right? Then and 9. Okay. Now let's see. So max. Now 1 point, so we had 1.1, and I'll compare that with 2.0. Okay. The advantage, as you guys can guess here, is that I don't need to define more and more macros for each of the combination data types. As in, whatever may be the combination, okay, for the first input and second input, any combination, essentially, you can use the same defined macro for all of them, given that the types are compatible enough to be checked, as in, can they be compared or not? That's the only restriction. Again, that is the restriction in general for the math operation. Okay, it's not the limitation of the code itself or the language. It's the limitation of the math, right? So if it is allowed, okay, so essentially this string gets pasted here, right? And at compilation time itself, it gets evaluated. Okay, and the evaluation will try to compare A and B, the literals itself, and see if they're compatible or not. Okay, so you'll get comparison issues if the arguments that you pass to the macro are not compatible. Nonetheless, uh, a single line can take care of all those cases. Okay, regardless. So that is something what we'll try to get in. So this is like this uses macros, but then one does not want to use macros always, right? So because they can be of sources of error. So we can do a much cleaner way using templates. So that's the motivation for this. Okay, so reducing code bloat, okay, without relying on specialized macros, okay, right. And here the body was simple enough, so we were able to use macros. But what if it is much bigger and larger code, right? We need a much more structured way to um, attempt the same thing. Okay, let's look at the actual thing then. the syntax goes something like this. So you start with the word template, okay? And you can write it as type name, as define something called a type name as T. Type name is the data type for the data types. In general, what I mean by that is you have inbuilt data types, right? Like int, double, float, and on so forth. All these types themselves can be treated inside a variable called capital D. Okay. In this example, what I'm showing, and the data type of all those types can be defined with a data type itself, okay, which is the type name. Okay, just a keeping things all consistent. That's the idea. So now look at the first example. Add integer max, integer a, and integer b, and only the thing changing was the data types. Okay, so integer become double in all these places. So I'll treat all these data types themselves as a new variable, okay, which is the capital T. I'll use capital T, okay, right, define function max, use capital T, define a, use capital T, and define a. So by default, all my definitions, my inputs and the output are of type capital T. Okay, right? And now I can just do the return data type. So if A is greater than B, return A, else return B. So this for clarity. And then yeah, then to format it. Okay. So next I'll define the main function. So A, let's say is 7, B is 9, C is 2.4, and let's say Q is 7.8. Okay, now let's start comparing. So standard C out. Okay, now I can do this max. Okay, so the way to use templated functions is you have to use the name of the function, give a single angular brackets. Okay, just covering the start and the end. Okay, define the data type. Okay, so whatever you're passing here, so essentially this guy, and then you define the template. Okay, so this is the syntax. You pass integer here. Okay, and then you actually pass the integers. So let's say a and b. Okay, and after that, and the line. Let's compile this and see. Oh, I did not run to. Okay, just checking. Okay, two, fine. Both cases it returns two. Okay, and if I have point one also equals to point one. Okay, so all good. Now let's run template 3. So it returns 9. So comparing A and B, okay, 7 and 9, the answer is 9 if the max of these two. So that returns it like correctly. Very similarly, we can also do perform a max of doubles, okay, which is for P and Q, okay, and 9. Now, yeah, so that should work. Okay, so 7.8. So the maximum of these two numbers, okay, 7.8. All right. If you go back to earlier classes where we had vector class, right? So this is a templated class. Oh, I should not jump on my bad, sorry. So think of it like also a very similar thing, but again, just since we're here, so might as well emphasize. So calling any of the class or data structure functions of it or anything, when you see a syntax like this, that is the template. Okay. So specifically, we're using the specific version of that function or whatever as the use case here. Particularly in this case, are integer. Okay, I'll cover this in more detail, but just so you guys are aware, this also has been always a templated class. Okay, right. So just keep that in the back of your mind. I'll revisit that also later on. Now, important thing here for now is that we defined a function max and we used the same function, okay, without changing it anything. So we just defined the template, right? Done. We were done with it. The only difference is that we had to pass template parameters, okay, and use the function to correctly run everything. Okay. The definition does not change for the data types, so it can be safely used for all of them. So one thing it ensures is that if you write it in this syntax, it ensures is that you have to have T as the data types of everything. Okay. You can play around with the data types for each of them being different or whatever. That's also possible and completely up to you guys. But yeah, for now, I'm just taking a single template. Okay, you can have multiple templates and use them accordingly. Okay. Right. Furthermore, you can also do it this way. So it's just another syntax for the same thing. Okay. So I write max, but not pass the template. Okay. I will just write it and call it A and B. That's it. And just pass standard name. And let's see what happens. Oh, that actually worked. Um, can you guys think why? So I'm saying that the template syntax actually looks like this, a little different than normal functions. So for example, here it's just a normal function, and this is how the functions get called. You call the function, you like basically call the function name, pass parameters, and you're done. Okay. The extra thing that you do for templated functions, okay, is a little more specialized functions. Less specialized in okay, different category of functions you can think that you have to pass the actual um, template argument. Okay. But in this case also, you were not required to pass it, right? And it actually worked. Can anybody think why is that? Okay, the reason is that the type of your template here, okay, gets reduced. What I mean by that is, so if I have the max function which takes a and b, and those a and b are integers, right? So it sees that it expects a integer a and integer b. So automatically it knows that the templated type that I am dealing with for this line, okay, is an integer. So the return type will also be integer. Okay. Because of the type reduction, a lot of times you don't actually need to explicitly mention the templated type data type. Okay. Right.
So this also works for UDT also, or just built-in data types.
Sorry, repeat.
So I am asking if the type needs to be explicitly mentioned, or basically in the third case, if
Mhm.
we are not mentioning it, it's deducting from the type of the data type,
Yes.
like
Yes.
isn't. So this also holds true for UDT also, or there we need to explicitly define
Utility as in
user defined types.
oh those yeah yeah, that also you do not need to. If it can reduce, okay, all
Okay.
good. Yeah. So templates are powerful in that case. So they do not restrict themselves to just inbuilt data types like integer or double. They can go to any user defined data types or any kind also. Yeah. So we can do a pretty similar thing for the second case also. So let's say max p comma q and then standard and line. Now, next double that's a and b. Okay. Now here I am sort of doing typecasting, right? because you know for sure that A and B, because this is an extra I'm studying. So you know for sure that A and B are integers, right? And the return type is also, by the definition of the template, is also of data type integer. So the return type now has the right hand side as integer, left hand side as double. Okay, right? You can do a pretty similar thing and just write, let's say, n equals to max p comma q. So the right hand side is now returning a double, okay, but the left hand side is storing it in an integer. So these are implicit typecasting. So if I run this, yeah, prints as expected. These two gets repeated, okay, and this one also I can just print. So compilation is all good. Now just print it. And N, M and N. Okay, now printing those. Yes. So typecasting, okay, removes like printing 9, which is an integer, yeah, as a double also prints it as 9 only. The only difference will say is for 7.8, okay, which is a double. But when printed as an integer, it will print just print 7. Okay. Right. All right. Okay. Something I wanted to cover. Oh, yeah. Okay. Uh, a very nice thing about another very big difference between this way of defining templates, okay, and particularly this method, okay, is that let's say you want to use certain data types, okay, and for that you had to write all these function definitions. Okay, that's how this would have worked. So you'd have to take every combination that you would have encountered for this max function and written all these definitions, right? For integer, for double, flip, for float, everything. Now, when you compile that, your executable, obviously there is a bloat, okay, which I'm saying that you don't need to, which you can avoid using templates. Like, how does that work, right? Let's talk more on that. So all these definitions, all this exist in your compiled executable. Okay, I think we can all agree there. There'll be a version for integers, there's a version for double, there'll be a version for float, and so on and so forth. Whichever thing I have written here, right? But let's say I take this templated example, right? And let's say my code looks something like this. Okay, just the template uh, definition. Okay, and I'm just calling some variables and just see out and then done. I'm done. Okay. So if I compile this code now, okay, there is a okay. Let's avoid that also. Okay, let's compile this. Okay. Obviously, this will compile fine because this is also a valid code. What do you guys think happens? Okay. Here, because I had to write for all the cases possible, right? Do you guys think here also it makes all those definitions? What I mean to say is, if I have the max function which is templated, right? What definition does it compile for? I just have defined it, and there is a main function because just because main function has to be there, and some declarations are there. They don't do anything, but that's okay. And the important thing to look at here is the max function, okay, which is of template type. Now, particularly here, what does that do, right? So what does it mean to have this templated function just as such? So if I compile this, okay, what does it compile to? That's what the question is. Okay. The answer, I'll repeat, it does not compile this function at all. As in, it will compile it, but it will not compile the particular body for a certain data type. Okay. Right? You can think of it like this function does not exist in, for all intents and purposes, this function does not exist in the compiled binary. The very, the reason for that, so 1 second. Okay, yeah, okay, fine. The very reason, and the reason for that is templated functions themselves get instantiated when they are called. Meaning, if you do not provide specific instantiations, okay, earlier, which also something you can do, but here I'm just talking about explicit instantiations where you're actually calling the function, okay. Meaning, if I call the max function explicitly with the template parameter or not, or time reduced or something, either way, if I'm calling the function itself only, that if it sees the body, if it sees that this specific version will get called, then it will make, then only it will make the version of it. Let's say the integer version of this max function. Okay. If I have this line, okay, I'll maybe clear it, make it more clear. If I have just this line, it will create the integer version of this max definition. Okay. Basically, here replace every t with integer and then compile this max function. Okay. If I have this double, okay, then it will generate a code for the max definition with all the t replaced with double. Okay. Now, what happens if I just have this double? Will it generate for both integers or double or just for double? Anybody?
But does it matter? I mean, templates are, so it is going to be like at the runtime only it can knows that you are passing integer or double, or is it a static time it can know. um, so you say if we just define template and not provide any like we are not calling this function max,
Right.
so this will not come. This there is no in the binary there is no definitions or anything for
Correct.
it template, right? So it's
That's correct.
going to be populated at the runtime.
That is half true. Okay. It's like, okay, what you said is up till the compilation, yes, if it can reduce the data type, okay, but not at the runtime. Reason being,
Okay.
templates do not get compiled at runtime. I'll tell you the reason. So let's say you have a code like this. Okay. It can the compiler can explicitly see that your max function is calling a version of max, okay, with a double parameter as a template parameter. Okay. So at compilation itself only, it will have the definition ready for a double version of max. Okay. Because it sees double, it will create the double version. If it sees the integer version also, it will create that version also. Meaning, if I just want the double version or integer version, I can just have that get compiled. So the automatic way of getting compiled happens with templates. If you do not call it, nothing gets compiled. So there is an inbuilt check to how much code load we actually want in our code. Okay. Templates are extremely useful for this. I hope you guys get the idea. In previous cases like this, you had to have all the definitions anyway. There was no choice for you. If you wanted to just have integers or double or anything. Because in case you want to use something else, you had to have all the definitions, right? But let's say some in one line, in some region of code, I just have double. Then it will compile only double. Because if it sees the whole code, okay, only the double definition, the definition for double only will exist. Okay. If it only sees integer, okay, then it will only compile for integer. So this way you can save space. But let's say it has encountered both, then fine, it will compile for both because anyway it is required. Okay, that's how templates work. And a very important thing to remember, templates have to be compiled time constant. Meaning, if I'm saying that the template definition here has to be integer, the whatever goes inside the template has to be known at the compilation time. And with the type deduction also, because we know the data types of A and B at compilation, right? Remember, C++ is a strongly typed language. So the variables need to have the definition, the data type known at compilation. Okay. So A and B both are known at compilation time, which is the integer. So the type deduction will work here. So let's just do this. Okay. So yeah. So at compilation, it knows that A and B are of integer. Okay. So the template explicitly writing this syntax is not really required. You can think of this line and this line as exactly the same. Okay, they're equivalent. Now, max definition, I require a definition with the integer parameter. Okay, that's what I'm saying here. So compiler will generate a code here for the integer version. And when you actually run it, it sees the definition that was generated in the binary and call it. Okay, call it line 15. The advantage again is that I need not have the double version of it. So it reduces my compilation time also. Okay, fine.
But we can also comment the code there in the earlier example. It's like at where we are commenting. Here we are commenting at this calling site, and
Right.
there I think, but both are, we know at the compile time that we don't want to call it, so we can comment it.
Yes, but let's say I have, okay, this is actually a single file. So this may not be little clear, but let's say I'm getting this template function from some other file, right? So I need not write the other file with all these definitions. I can just have the template type. You can think, the reason because templates actually need to know the complete body and whatever they want to get compiled in it, it should be known. Okay. Hence, I'm putting in the same file. They have little nuance. If you try to put them in different files, but for sake of argument, just um, think it this way. Let's say I call only double, then double only get compiled. That is the essential idea. Can you repeat what you're saying though? Maybe that is the what you're trying to clear. So, oh yeah. So it's like you're saying if I have just a specific instance, I can comment it. That's true. That's absolutely true. But it's like if I want to use a specific version of Max, okay, from derived from some function or from some class, okay, I did not worry about what it was actually defined with, okay, or was all the body definitions, everything was written or not. I do not need to worry about that. I'll just call the Max function which I require. That is the essential idea. So
Yeah, it's
you
like
have,
it's this is
yeah,
more convenient to use kind of thing.
exactly. Exactly. It's just very convenient to use.
And if we have a function name exactly same name as Max, so this will error out, right?
Of course. You still run into I mean, so C++ works that the fundamental way this whole thing works is you still maintain the backwards compatibility. Meaning, if I have a max function, okay, with exact data types, right, redefined again. So if I have integer, that's okay. So, okay, let me take this example. So I have one with integer, that's fine. I have one with double, also absolutely okay. But if I repeat the same code again with integer, That's an error because it doesn't know which definition to call, even if they have both have the same body. Okay, right? So because it does not know which exact function to get called,
Mhm.
that does not happen even with templates also. You'll get the same error. So
But
see,
let's say I am calling this template with argument type double, and I have a
yeah.
function which take the arguments as a type int. Then, uh,
No,
then
so
in that case,
templates.
so
So
it's
that is okay. So you can explicitly say that I want the definition of the double, but I'm
yeah.
passing integer, right? So here it will have a typecasting then.
No, no, no.
So
So
mm,
I'm saying, so this line 13, I want to be it exactly like this, and 15 also. But
okay,
I have a function name max also,
okay,
which are taking argument of type integer.
that is fine because it's a different max where it explicitly takes integers, but what's the return type then? Is if it's integer, then it will throw error because integer with like all this t being integer already exists here in this line.
Mm,
What I'm saying is when you actually call the function, you can think like this way. When the function gets called, it needs to see the definition already, right? And because it's a template function, compiler will generate that body then and then only it will generate. So our definition of max, because a and b are integers, our definition of max with all integers as an integer max, integer a, integer b will exist in the compiled code. On top of that, if we had another max, okay, with integers, that will throw an error. So let's say I have this. Okay. So that's actually called template instantiation. So you can have specific instances of your template. You can do that. Okay. So let's say I do integer a, integer b, and this actually does nothing. Okay. So it actually does it requires a you see that it actually returns zero. Why is that? The reason being because your max function already has a specific definition of that instance, right? It will use that definition. It doesn't need to generate it because it already exists. Okay. But
yeah, right. That is what I'm asking. Right. So it didn't error out
yeah,
if it has a different definition. Um,
yes.
okay.
But let's say if this was this way, uh, it specifically is using the double one because the return type zero is also okay with it. Meaning it sees this definition. It has two integers, all good, and it returns the double version of it. It doesn't need to return anything. I mean, it doesn't need this version specifically to use. That's what I'm saying. Okay. All right. Very good. Yeah. So that is the important thing to remember about templates, that their specific version definitions only exist when a specific instance of that class is called. Furthermore, you can specialize the class as in your max function, like you see here, I have a specific version of that max, okay, with the return type just zero. It does not use this body. Okay. So for specific instantiations, you can specialize it to have different body. Okay. So for let's say integer data type, I want to have a certain body of the function. You can do it that way. For the rest of the cases, you can have a generic data body for that uh, templated function. Okay. Any questions? All right. Okay, moving on. So, as templates, very similar to templates in general, where we use it for functions. We can also define our classes to be template data types. As usual, we'll include the header ISTM to print stuff. So the syntax goes something like this. So very similar to previous. So you have template and then you're giving type name, right? So give type name, then we'll write the function max. As in, sorry, not the function, the class max. Okay. So it will have internal variables, P, A, B, a public function, which actually compares. Okay. So this is the constructor itself. So max takes uh, A, B, and use this operator. Okay. So I'm referring to the internal variable A, okay, which is being set to A, which I'm getting from here. Okay. I can use this operator again, set B to B. Okay, so this is the constructor. Constructor takes two values and sets it to internal variables, which are A and B again. Now, the max function itself is also, I'm taking it as a template type. So max function just returns, it's basically the same function that we saw here. Okay, this so happens to be in a class format. So it compares A and B, A, B, and C. Okay, so now inside the name, first of all, I need to um, declare object of this max. So let's say it is the name of the object is n, okay, and it takes 1 and 2. So this creates the object, a sort of instance of this class of the class max, and the variables a and b internally are set to 1 and 2. Okay, fine. Now I can take it a little further. Oh, my bad. Um, very similar to uh, functions where you were calling it as max, let's say the function name and then giving templates here. Very similar to that. You have to give your integer template, the name of the template or the template parameter specifically here. So max integer n takes 1 and 2. Okay. And n dot max is the function owned by the class. So to access that function here, max, which is small letters all, I'm using the dot function of on m. Okay, I don't need to pass anything here because it already has the information of f, a, and b. So I can plain simply just print that. Okay, I'm good. Let's compile and test. So that prints two. Okay, and uh, like before, if I did not have it, okay, so if I compile, also works again because it reduces the type from at compilation time. Okay, again remember templates need to be known at compilation because if this it has to use this whole function templatized classes definition, it needs to know what T is, right? Otherwise, how will it compile it? And C++, again, a strongly typed language, it needs to know how much bytes it has to allocate for all of these pieces. Okay. So if it does not know it is of integer data type, it can't do that. Okay. So templates by the standard itself are compilation like that they are uh, defined at compilation time. Okay. Any questions? Okay. Let's take another example. I have a templated type again. So type name. If the class is minimum. Okay, this time. Now, um, I'll follow the same syntax as before to compare. Um, okay, so let me just do this way. This is the syntax for max. Okay, now give me a second. Okay, yeah. So this is the syntax for max, and we can have very similar syntax for even for min. So technically, you can make a compare function, and different the constructor just constructs everything. Okay, and each of the function gives you the compared value. Okay, so a single templatized class can take care of all this. Okay, so let's just do that. So I can do a compare B A B and then public compare specifies I'm specifying that I'm setting A to A as in the A from owned by the pointer owned by the class itself. Okay, and it's access like this. Then the max where the return is it is A or if A is greater, then you return A, and so return B, and then enter. Very similarly, we can make the main function. Where if A is greater, we swap it. Okay. Again, very useful. So what we did is we combined the ideas of templates and classes both, right? Um, in a single structure, you can have different all the data types taken care of, and you can add all the comparisons itself as different functions for for you to just access, right? For the main function and compare. Okay, I'll just make an object easier, and let the two numbers be 1.5 and 4.5. Okay, so I can print both of them. So I'll have ob object objs max. Okay, I can print the max of the two values. Pretty much the same. I can print the min of the two values. Okay, now let's compile. Okay, so the minimum again is obvious. It's 1.5 and the max is 4.5. Okay, right. We'll take pretty much the same thing. Okay, but this time, think of it this way. What if we want to compare data types, okay, which are compatible but different? So far from starting here, again, probably previous also, what, yeah, here also, what we were ensuring is that the input parameters both have the same data type, okay, and the return type is also of the same type, right? So again, necessarily, it's not necessary that when you are comparing two numbers, they need to be of the same data type, right? Like one could be of integer, another could be of double. Okay. So, and certain case, case like that was actually handled by the macro. So if we want to not again go back and use this macro, right? So let's see how we can do the same thing in templates, because while templates were able to uh, take care of this case, like make it much more simpler, and furthermore give a lot of advantage in code compilation, like saving time, of course, and avoiding the bloat of all the definitions. Okay, while template did do that, can we get this example, which the other case that even the macros take care of, right? Can we get that edge case also under this under the umbrella of templates? Turns out we can. So let's look at that example. So yeah, the max example, the compare class where you have both min and max both together. Okay. So what we can then do is take the same compare function, add more templates. So type in T2. So T1 is template 1. Okay. T2 is the template 2. Now what you can do is define it this way. So now your template A is of type template 1, B is of type template 2. Okay. You can change all this now to accommodate all the definitions. Yes. Now comes the choice. What should be the return type? That you can fix to one of them. So let's say I'll always pass the first argument as double or maybe integer. So in any case, let me for now just let me for now just make it T1 so that it always returns the data type, which is the data type of A. You can specifically mention here double. Okay, that is also valid. Nothing stopping you, because there'll be some internal typecasting, and all the data types that I'm going to pass are compatible. So like integer, float, and so on and so forth. So returning any of them in double format is also not a illegal move to do. So you can just have it as double or smash it T1. For now, just keep it as T1, and that should be good to go. Okay. All right. Now let's run the same thing. Uh, yeah. Let's see how this change that we brought about is going to affect. Okay, so yeah, max again is 4.5, so not a problem. min is of 1.5. Okay. So it deduces the data types. Okay. So of T1 and T2, the templatized class is now deduced from here. I need not explicitly mention it. The variables get is set, okay, instantiated also you can say. And lastly, the data type of T1, the max and min functions also determined from the first argument. The first argument is of decimal, so a real number. So specifically one has to use float or double, right? In general, it defaults to double, okay? So it will use double and then you can print all these values. Okay, right. Next, take another object. So let's say I make another object. Let's just extend this. So object two, and let's say the first argument is integer, okay, and second argument is float number. Now what happens when we print? Format all this is done. Okay, that wasn't. All right. So now let's type and print. Okay. So 4.5 and 1.5, those two as expected. In the second case, if it's max of these two, so 4.5 again. Sorry, 4.5, yes, is the max. But remember, for object 2, the deduced data type is of the first one. So it is of integer. So the return type also get implicitly casts it to a integer minimum also. Okay, so minimum is 2. So casting 2 to integer to a integer, not a problem. So you get the actual exact answer. But the max, which is of 4.5, gets typecasted to integer. So you see as 4. Okay, same exact thing, but if you just interchange the order of your parameters, right? Changes the answer. So, right? So as you see the answer, because it returns in the double format, so the max gets printed exactly. And the return, which is, let's say, the return for second one, which is of minimum. Minimum is 2. Again, 2 does not change when converted to double. So you see that number is 2 again. Okay. All right. Any questions? Okay. Moving on. Oops. Uh, let's look at templatized classes a bit more. Something what um, your STL will have. Okay, I won't write the complete thing, but something along the lines of part of it, which you guys can follow now. So let me define a template. Okay, let's say it's of type name is some generic T. Okay, so let's call it a class A. Next, what I'll do is I'll use the standard vectors. So vector needs to be needs to always have the templates. So I can just make a generic class templates, my generic T as a template for my vector class standard vector. Okay, and let's call it B. The nice thing is that I do not need to know the data type of standard vector. I can extend the same thing. Whatever my class will reduce, I'll just use the same data type. Okay, that's a very powerful thing about using templates. You can get it sort of passed down. Okay, for all the member variables also. Let's do that. We'll make init function, which is let's say size underscore t, and there it sets the size of the okay. Size underscore t, if you guys recall, that's the highest integer representable in your system. So that's the idea. Because V is a vector class, I don't really need to know what the data type is, but I can use the resize functions and all other methods that I have with it. So init function of this class just takes my argument and resizes the internal vector to that many elements. Okay. Only thing I need to uh, create is domain. So the only thing I need to do is create the object of A, okay, with the appropriate templates. I'll just create it as an integer, right? And then all the init function, let's say pass 10 to it. So it will create 10 values inside the standard vector because of the resize function. And in all this, the template T, since it decides what the data type of V will be, my creation of the object already ensures that. Okay. This is another use case. You can use templates in conjunction with not just class templates, you can use it with function templates and yeah, combine it with different functions also like this. Okay. And here you can even take it further where you're defining different template types itself for the same class. You can make it T2 also. So the return type will be of minimum is decided by the second argument's data type. Again, anything works. All right. There's another thing I can, are there any questions so far? Okay. So polymorphism, specifically polymorphism in the context of templates. Okay. This is pretty much straightforward. So let's say I have the first I'll include the string. So I'll include the vector class. First of all, define the base class. So class void init, okay, and that has size underscore t as template data type and n as the template. Sorry, input parameter. So it does not have any body yet. That's okay. And then I define the derived class. Okay. So template. Now what I'm going to do is make the derived class as template. Now B, I'm just going to derive using B. Okay. The member variable will have a standard vector B, and the standard vectors template is defined as T. Okay. Now public void init. So this init is sort of overriding the definition already existing inside the base class of n. Okay. And I'm just going to say size to n. Okay. And then all right. Now I have the main function. So the object B is defined for the base class, and for D, I'll define small d. But remember, you have to have your, because there is no way to time reduce, you have to mention the templates. But the nice thing is that the base class is not templated. Okay. But you can have as many templated derived classes. So this is allowed. Okay. And yeah, furthermore, you can actually choose what your template you want it to be. For example, um, let's say there is a function, okay, which takes t and n or something like that. Okay. And inside that, all this is commented. Okay. And inside that, you define all these things. So D as B and so forth. D as, now the definition of D will depend. So let's say your D is integer. Okay. So you would want D to be declared with integer. Something like that. Okay. Yeah. Another thing you can do is you can always do this, right? Set object of D inside B. Remember from typecasting rules, you can always have the base class storing all kinds of derived classes, pointers, and everything, because the base class will always have whatever definitions inside the derived class. So B equals to D can be done. We'll just use the same idea, like just do D's thing, but not define the variable. Sorry, just use the definition that I'm going to construct a derived class D of integer templatized and store it in B. So this way you can do for else part also, where you're saying that say my t is double, then this is yeah. equals the template double construct what. All right. So depending on what exactly your use case is, you can set your B accordingly. You can write switch cases also, absolutely fine, right? But nonetheless, this is also something you can do where you're taking your template parameter, okay, and the number of elements in your vector from some function, and you're calling this all this inside a function. You can set variables of the objects B and B through this, okay, just because your derived class is a templatized class. Another thing here is important, very much like how functions, we go there and show you guys. Yeah, very much how unless you actually explicitly call with a specific template, that function definition does not exist in the compile binary or memory or whatever you want to think about. Very similar to that, even in um, classes in general, all these examples, unless you're actually calling a class with the definition, right? Like instantiating the class, the templatized classes don't exist. Okay. All right. Okay. Right. This is all what I wanted to cover today. So yeah, if you guys have any questions, you can feel free to ask. Else, yeah, you can feel free to leave.
So the syntax remains same if we are using the pointers. So let's go back to the max example, the basic one. And if we are accessing, if we are specifying the integer, let's say int a equals to maybe new and assign them a value, the syntax will work, or we need to change something in the syntax of the template.
It should work. You just dereference that pointer and pass it. That work. Yeah.
Okay, so dereference the type name, like we
You
usually
reference a
do.
pointer. Yeah. Let's say you define here a as sorry, this a, let's say integer pointer a and then
Mhm.
defines the value. Instead of passing a here, uh, or like specifically passed values. So instead of passing just a, you just dereference and parse it. That's fine. Because then it is actually an integer you're passing, right? You can actually pass it also this way, a of 0. So you're passing that specific value.
Yeah.
Because it expects integer variable. So the specific value itself can be passed. It can come from a pointer, dereference pointer also. That is absolutely okay. Was that the question or something else?
Yeah, in respect to templates, it
Yeah,
should work, or do we need to change? So it should work as it is.
it should work as is. You can, it's exactly like a function. You can
Mhm.
do it here also. Specifically here in this case with templates. Uh, yeah, you can just dereference your A and B. So like we define it as specific integers, integer variables. But if you define it as pointers, you can, not nothing stops you. But when you dereference it, you're actually accessing the integer itself, right? So the template, sorry, the parameter data type will respect that for the function. And yeah, that should work.
Actually, in the notes for character type template, there was a the syntax was a little bit different. So it was like template with empty less than greater than sign, and then
Yeah,
specifying explicitly.
right. So that is actually more specifically, I understand what you're, that specific one I understand. So let's say this is the thing. I can do it this way. Uh, I should maybe not do this. I should do this. Yeah. So this is the actual templatized class. Okay. This is a specific instantiation of that class. So where you do not say what is the data type, as in you don't need to actually, you just explicitly mention the data type and explicitly write the body of it. Meaning to say, I want my specific instance of this template class wherever if I'm using the character or integer in my case, character in your case, we use this definition of the templatized function. Very similar for classes also. I mean, you can templatize classes even. So this is something called class specialization. You're specifically instantiating your function, templatized function. So this is called specialized. Okay.
Okay, thank you.